All right, so we're still focusing on that idea of a constant rate. In the different forms, we can find the constant rate. So this one says, this graph right here says the figure below represents Nathan's constant rate of walking. Okay, so let's review how we read a graph. Our x-axis here is the time in hours. Okay, so this tells us 1 hour, 2 hour, 3 hours. Our distance in miles is on the y-axis. So his constant rate, remember his rate or his speed is distance divided by time. And the truth of the matter is, guys, it's basically like finding the slope. It's finding our rise over our run. So if you pick 2 points, actually, like pick these two. Again, being careful to watch our scale. We're not going up by ones. But if I go up 1, 2, 3, 4, 5, 6, 7, 8, and over 2, 1, 2, I would get my slope of 8 over 2. Or maybe I pick this point right here, and I'm going up 1, 2, 3, 4, and over 1. Well, that all equals the same thing, okay? Our rate, our speed is 4 miles per hour. So we can tell his constant speed by looking on the graph, okay? Now we have Nicole. And Nicole just finished a 5-mile walkathon. Good for her. It took her 1.4 hours. Now we're going to assume that she walks at a constant rate. When I think constant rate, I'm thinking y divided by x. Y is the distance, x is the hours, and we want to describe Nicole's walking speed as a linear equation in 2 variables. So take our rate, 5 miles in 1.5 hours. Remember, our time always goes on the bottom. And now match it up with our y and our x. Y is the distance, so that's going to be the miles. X is the hours. Now use cross products. 1.4 times y equals 5 times x. Always solve for y, so we're going to divide both sides by 1.4. And we're going to get y equals, well, kind of a crazy number here. So just for what we're doing right now, I can approximate it. Maybe 3.57 approximately. So this is going to be 3.57 times x, okay? So who walks at the greater speed? Well, Nathan walks 4 miles per hour. Nicole, how do we figure out how fast she walks? Well, we already did. That slope, that constant rate, that's her speed. Okay, if she walks 1 hour, it's 3.57 times 1. If she walks 2 hours, it's 3.57 times 2. So Nicole walks 3.57 approximately miles per hour. Who walks at a greater speed? Well, last time I checked, 4 is greater than 3.57. So we could say Nathan's, sorry guys, it happens every time I try to go fast. Nathan's rate or speed is greater well, I'll just say Nathan's rate is greater from this right here. And we'll take that as our explanation for right now. Okay, so notice we had this information in 2 different ways. We were presented it as a graph and as like a story problem, but we are still able to find the same information, even though it's not the same, they didn't have the same rate, but we could still find their rates, even though it was given to us in different forms. One more example. All right, so Susan can type 4 pages of text in 10 minutes. Assuming she can type at that constant rate, that's important. Write a linear equation. Well, if we're writing linear equations, that's y over x. And remember, I'm going to put time on the bottom. So I want to go 4 pages in 10 minutes. And that's going to go with my y pages in x minutes. 10y equals 4x. This should all seem familiar, guys. And then I always solve for the y, so I'm going to divide both sides by 10. And we get y equals, now we can reduce this to 2/5 times x, or you could say this is y equals 4/10 0.4 times x, either way works. So this one we're given the information, we had to figure out the equation. Now part B here says, the table values below represent the number of pages Anne can type, y, and a few selected minutes, x. Assume that she types at a constant rate. So, constant. Remember, if I wanted to find her constant, I would do y divided by x. Here's the y's, here's the x's. Pages typed per minute. So that would be 2/3. Now it tells us it's constant, so unlike 7th grade where we had to prove something was constant and I'd have to try all of them, we know it's 2/3. But I want to show you something. Because sometimes we're like, well, it can't be 2/3 because 10/3 divided by 5, or 5/1, isn't going to be 2/3. Watch what happens. Keep it, switch it, flip it. And if I multiply straight across, I get 10 times 1, which is 10, 3 times 5, which is 15, and they both have a common factor of 5. So if I divide a 5 out of both of them, 10 divided by 5 is 2, 15 divided by 5 is 3. So notice we get 2/3, and that would happen for all of them. So if it wants to know who types faster, we have Susan, who does, well, I'm going to write it in a couple ways. Let's just start with this. 2 pages in 5 minutes. And we have Anne, who does 2 pages in 3 minutes, 2/3. Remember, pages are on top, time always goes on the bottom. We can totally find a common denominator, or I can kind of approximate it. If I go 2 divided by 5, like I wrote above, that's 4/10. And 2 divided by 3 is going to be 0.6 repeating. So who types faster? Well, I know that 0.6 repeating is greater than 4/10. So we're going to say Anne, or Anna, I'm sorry. Is it Anne or Anna? Anne. Oops. Anne types faster because her rate is greater. Hopefully you can see in this lesson that it's really nothing new, but our knowledge of all these terms in the math hopefully has gotten stronger. So before, when we might have struggled trying to find a linear equation, hopefully we're a little more comfortable there. But I really hope we're more comfortable at understanding this constant and how to find it, whether it be, finding a constant like this, or writing an equation, or on a graph finding the slope. Again, constant rates revisited, and hopefully our understanding of what that constant rate means is greater than it was before.